Algebra 1, Lesson 37, we are looking at scientific notation and being able to go back and forth between standard notation, scientific notation, and then also being able to multiply and divide with scientific notation. So if we are going from scientific notation to standard form, remember those powers of 10 move our decimal place. That's really a helpful way to think about this. So if I do 1.08 times 10 to the second, I'm going to move this decimal place twice to the right. Okay, because we have a positive exponent, I'm moving to the right. So I move it, let's get that my pen working, and I should get 108. Okay, move it twice. Let me fix this. All right, we move it twice and we get 108. And for the second one, we move it 3 times, and in the empty space would put a 0, so I have 1,080. Next, we move it 4 times, we get 10,800, and so on. Now, if I have a negative exponent, I move it to the left. So I'm really dividing by 10, so I get 0.108. And the next one, we move it twice, fill in the empty gap with a 0, and get 0.0108, and so on and so forth. So, being able to go from scientific to standard, use those powers of 10 to help you. Now, if we want to write something in scientific notation, we need to remember that my number that's in front of my power of 10, it needs to be between 1 and 10. It can be 10, it can't be 0, but it needs to be something in between. So with my first one, 856,000, I say, well, if I want all of this information, I can put 8.56 here. And to be able to get to my original number, I would need to move my decimal 5 times. Okay, so if we had it right here, I would need to move it 5 times to get there. And on my other one, I would say, okay, I have 5 times 10 to the something. Well, since this is a small number, it's going to be negative. So if I have my 5 right here, I need to move it back 1, 2, 3, 4 times to get my original number. So it's 5 times 10 to the negative 4th. Now we can do scientific notation on many different things. Okay, really big numbers like my 7,960,000,000, and I would say, okay, 7.96 times 10 to the, well, 1, 2, 3, 4, 5, 6, 7, 8, 9. Or we could do it with regular numbers like 45.668. Now, may not be very helpful, but we can still do it. 4.5668 times 10 to the first. I would just need to move that decimal once. So we can do all of these numbers in scientific notation. Is it helpful for all of them? Not necessarily. We're not getting rid of a lot of zeros or anything like that. Remember, scientific notation is useful when we're able to take really big numbers, really small numbers with lots of zeros involved, and condense the information to help us and not have to count as many zeros. Now, what if we are given something that looks like scientific notation, but we realize is not in proper scientific notation? Like the first one, we have 19.5 times 10 to the 11th. Well, we need a number between 1 and 10, and 19.5 doesn't fit that. So I know that I'm going to need 1.95. Now, there are a lot of ways to think about this. Logically, what we are doing is saying 19.5 is the same thing as 1.95 times 10. We're basically pulling out a 10 from that 19.5 and saying, well, that's the same as 1.95 times 10. And we have our original times 10 to the 11th. Well, when we simplify, we are really having 1.95 times 10 to the 12th. Another way to remember it, okay, to remember what's going on here is if I move my decimal back, I need to move my exponent up. I need one more 10 to move my decimal. Okay, and let's say we have 0.195. Well, I know I need 1.95, and I really, to get that, I need to multiply by 10 to the negative first. I move my decimal. Okay, and we have my original times 10 to the 11th, which means I have 1.95 times 10 to the 10th. So if I move my decimal forward, I'm going to move my exponent down. So my 19.5 times 10 to the negative 11th, I'm going to have 1.95 times 10 to the, well, remember, move it back, so move it up. And what's before negative 11? That's negative 10. And then we have 1.95 times 10 to the, well, we move it forward, so I'm going to move my exponent down, so I get negative 12. Okay, another way that you can remember this is how many times do I need to move that decimal, and think about, do I need to move it more or less with my new proper scientific notation. Now the other part of this lesson is being able to multiply for scientific notation. And we have two steps. We multiply our two numbers and then multiply the two powers. And the reason that we can do this is because of the commutative property. I can rewrite this to say I have 3 times 2 times 10 to the third times 10 to the fifth, so that I can multiply my 3 and 2 to get 6. I can multiply my powers to get 10 to the 8th, and I am done. So I'm multiplying my two numbers, multiply the two powers, and I'm good to go. But what happens if we multiply them together and we get something that is not in proper scientific notation? Like if we take 5.7 and multiply it by 1.8, I get 10.26. And we have that times 10 to the 8th. Now that's not in scientific notation, so I need to move my decimal back. So I move my exponent up. So 1.026 times 10 to the 9th. And then dividing is just like multiplying. We divide my two numbers and then divide my two powers. So we do 6.8 divided by 2.5, and we get 2.72 times 10 to the something. Now, if we're dividing things that have the same base but different exponents, we subtract the exponents and get negative 3. And we're good to go there. And then we get, for my second one, 0.125 times 10 to the negative third. So to put it into proper scientific notation, I move my decimal forward. So I move my my exponent down. Okay, so I have 1.95 times 10 to the negative fourth. So what we're saying here is I would need to move my decimal place 4 times to the left rather than only 3 to get my number, which is true. All right, and then let's put some context to this. So if we have, and I'll do it on this page, if we have the speed of light at 3 times 10 to the 8th meters per second, and if Earth is 1.47 times 10 to the 11th meters from the sun, how many seconds does it take light to reach the Earth? Here, hold on for just a second. All right, so we need to figure out how many seconds does it take for light to reach the Earth from the sun. So we look at these and we say, what operation do we need? Well, we can plug it into my distance equals rate times time to get, to say that, well, my meters is my measure of distance. My 3 times 10 to the 8th is a measure of rate. So we plug them in, we say, well, I have this, I need to figure out what the time is. So I divide by 3 times 10 to the 8th. So I get 0.49 times 10 to the third. And I put that in proper scientific notation to say 4.9 times 10 squared. That means that it takes 490 seconds to reach Earth from the sun. That's about 8 minutes. Okay? And if you want to go ahead and try out this last example, remember, use your distance equaled rate times time. And so if we have the distance light can travel in 1 year, remember light travels 300 million meters per second. Okay, and there's 31,536,000 seconds in a year. So that's 9 quadrillion, 460 billion, 800 million. Oh, it's even bigger than that, right? 9 quadrillion, 460 trillion, 800 billion meters per year, or 9.46 times 10 to the 15th meters. Okay, pretty crazy. All right, and the speed of light is 3 times 10 to the 8th meters per second. If Mars is 2.25 times 10 to the 11th meters from the sun, how many seconds does it take light to reach Mars? And this is just like the other one. We are going to take our distance equals rate times time, and we put in our distance as 2.25 times 10 to the 11th, equaling my rate of 3 times 10 to the 8th, multiplied by time. So we're going to divide by 3 times 10 to the 8th. So when we get my powers, I get to the third power, and 2.25 divided by 3 is going to get us 0.75, but that's not in scientific notation, so I move it back. So to get the same thing here, normally we would get, 0.75 times 10 to the third. Okay, we move it 1, 2, 3. So we have 750. So really, if I have 7.5 needing to be 750, I really only need it times 10 to the second. So 7.5 times 10 to the second. So it takes 750 seconds to get from Mars, or from the sun to Mars. Well, I hope this is helpful for your homework and for studying.